So suppose we have the following arrangement of resistors. You've got an 8 ohm resistor in series with a 4 ohm resistor, and then the wires split. You've got a 6 ohm and then a 3 ohm resistor, and then they come back together. And we're from A, sometimes we call this A and B, we just pick spots. Let's say there's a total drop of 42 volts across those resistors. And we want to know, A, what is the equivalent resistance? What one resistor could I put in place of all of this? And then, what is the current in each resistor? Okay, so the very typical kind of problem. So let's solve it. Well, here's what you got to do. When you're going to break down a circuit, you got to look for resistors that are in series. The first thing I do is look for resistors that are in series with each other. What does that mean they're in series? It means you've got one current flowing through both of them. Okay, now look at these two right here. One current flowing through both of them. They're in series. So those two are in series. Now then I look for resistors that are purely in parallel. These are in parallel. Now how do you know they're in parallel? Because all of this stuff is at the same voltage. All of this stuff is at the same voltage. So when you jump across this, or if you jump across this, you're going to drop down the same amount of voltage. So therefore they are in parallel. That's how you define in series for capacitors and for resistors as well. Okay, so now if you have resistors in parallel, what you do is you take this and say that this resistance, and let's call this R1, R2, R3, and R4, and then here are the resistances of each. When I combine two resistors, after I put a little subscript next to them, I just combine the subscripts. R1 and 2. R1, 2. Well, these are in series. So how do I get the total resistance if they're in series? I just add them together. So it's just going to be 8 ohms plus 4 ohms is 12 ohms. Then I take a look at R34. Now they are in parallel, so I need to use that parallel parallel resistor equation. And what I'm going to do is kind of do it like this: 1 over R3, which is 6 ohms, plus R4, or 1 over R4, which is 3 ohms. Now, by the way, if this is if these are not simple ones, you know, where you can find a common denominator and just flip it around and stuff and do it easily like that, just use your calculator to do it. But this one is kind of easy. This is basically 1 plus 2, 1/6 plus 2/6 is 3/6, right? So reciprocate and multiply, that's 6 ohms over 3, which is what? Am I still on screen? 2 ohms? And this makes sense. The resistance for resistors in parallel, the overall resistance is less than the smallest resistor. My smallest resistor is 3. Now, here's what I'm doing. Here's why the resistance is less. Imagine I only had this 3. Imagine that there was only this 3 ohm resistor, right? What do I do by putting this 6 ohm resistor in parallel with it? I'm just making the wire bigger. I'm giving it another path. So that will allow more current to flow for the same voltage drop. Well, more current flowing for the same voltage drop means the overall resistance is less. It's going to be less than your smallest resistor when they're in parallel, the equivalent resistance. So now what I'm going to do, now that I've combined these two and combined these two, I'm going to redraw the circuit. So here I've got a 12 ohm resistor, and now that's going to be in parallel with a 2 ohm resistor. In series with. And this is this is R12, this is R34, and now what do? I just add them together. So the equivalent resistance is just 12 plus 2, 14 ohms. In other words, I could replace all of this with a 14 ohm resistor, and I get the same current flowing. Okay, so that's part A. Okay, make sense? Now I want to find out, well, okay, given it's 42 volts from here to here. Now I'm going to figure out what the current is through each resistor. Well, first start with the whole thing. Basically what we've got is one 14 ohm resistor, right? This thing is like, let's do part B. This is a 14 ohm resistor. This whole thing is a 14 ohm resistor. So I can figure out what the total current is. So I total, well, use Ohm's law. Let's just start off with Ohm's law. Delta V equals IR. Now you can treat the whole thing. This applies to the whole thing. So I know what delta V is. It's given to be 42 volts. I just figured out what the resistance of the whole thing is. It's 14 ohms. So I can figure out what I is. I is equal to delta V over the total resistance, 14 ohms. And happily, that just goes in nice and evenly. That goes in there 3 times. Remember, an ohm is a volt per amp, so the volts cancel and you get amps. So this is going to be 3.0 amps. So that's the total current in your circuit. Now I'm going to kind of take the next step up. I'm going to say, okay, well, what's the, actually what I can do is I can go back and look at my original circuit. 3 amps, let's look up here. If I've got 3 amps flowing through the whole thing, do you see that there's 3 amps through this and 3 amps through that? So does that make sense? All the current flows through R1 and all the current flows through R2. Okay, so I can say that I1 equals I2 equals the total current, 3 amps. So there's that answer. But now I got to figure out this. Now here's the way I'm going to do it. I'm going to figure out what the voltage drop is across these guys. Well, how do I do that? Well, let's figure out what the voltage drop is across these guys. But these two are at 12. I know I can say, well, delta V equals I, which I know is 3 amps times R. But R for these two guys combined is 12. So I'm going to call it R12. So now I can plug in 3.0 amps times R12, which is 12 ohms, which is a volt per amp. And so this delta V, and this is delta V for 1,2. Well, what's 3 times 12? 36? 36 volts. Well, what does that mean? That means that when I go from here to here, I've lost 36 volts. But I also know that from here to here, it's 42 volts. So if I lose 36 volts from here to here, what's the voltage drop from here to here? So that means delta V 3,4, for both of these, is going to be equal to 42 volts minus 36 volts. Because this voltage drop plus this voltage drop has to equal 42. And what is that, 6 volts? So that means that, hey, I know what the voltage drop is for this resistor. It's 6 volts. So now I could just say, well, I equals delta V over R. And let's do the resistor 3. 6 volts divided by 6 ohms is 1 amp. That's for I3. And then I4, delta V 4 over R4. Oops, sorry. Tell me if I'm off screen. Well, what is this is 6 volts, right? From here to here, it's 6 volts over 3 ohms. And 6 divided by 3 is 2. So 2 amps. Now, does that make sense? Well, what's the total current? The total current is 3 amps. Well, 1 amp is going through here. So that means what? I better have 2 amps going the other way, because it's splitting up the current. 1 amp goes through here, and we just calculated that 2 amps goes through here, and 1 amp plus 2 amps is equal to the 3 amps that came in. That makes sense. That's another way of checking your work. So, gee whiz. So, I1 equals I2 equals 3.0 amps. I3 equals 1 amp. And I4 equals 2 amps. And I'm done with the problem. Okay. And each individual little step, like I said, it's not hard, but you got to put it all together. That is all.